All right, today's lesson is 15.2, trig functions of non-acute angles. Our last lesson was on just acute angles. All right, so there's going to be a new term that we'll be talking about today, and it's called a reference angle. All right, so a reference angle is for any angle theta, and it'll be written as theta prime is how you say that. It's just like that little tick mark. And it is the positive acute angle made by the terminal side of angle theta and the x-axis. All right, the big things to focus on that it is positive, and you are always going back to the x-axis for this angle. All right, we'll show you what some pictures look like here. So in our coordinate plane, we've got 4 quadrants. Quadrant 1, all of your angles would be positive, and they all go back to the x-axis as the same value. So quadrant 1 does not change for a reference angle, but we'll look at quadrant 2, a picture of that, quadrant 3, and quadrant 4. Just a little sketch. All right, so if I have some angle that lands in quadrant 2, so remember this would be your starting, and then just draw a ray somewhere in quadrant 2. That would represent theta. All right, so when I calculate the reference angle, it is the angle, so my theta prime will be this region right in here. So it's the measure that it makes with the terminal side, so where my angle ends, and the x-axis. All right, so if I was to drop down a right triangle here at that spot, I'd be using that angle. All right, I've kind of already shown you that before we defined it as a reference angle. So if I was calculating this, let's do, what do I want to do? I want to do an example. So let's say theta is 155 degrees. And I want to figure out what is theta prime. Okay, so when I look at that, I should see that, well, it would make a straight line right here. So if I take 180 minus 155, that will give me the measurement of that reference angle, or theta prime in this case. So 25 degrees. So it is a positive measure from the end of your angle to the x-axis. Okay. Let's look at one for quadrant 3. So here's where it starts. I want something to end in quadrant 3. All right, so that would be theta. Okay. If I wanted the reference angle, so here's where this ended, but I need the positive measure back to the x-axis. So that little red blob would be the measurement of my theta prime. Okay, so if we did an example here, and I say theta is 218 degrees. Let's find theta prime, so the reference angle. All right, so if I know a straight line makes 180, I need to figure out how many degrees past 180 that would be, and that's going to be my reference angle. So I need to take 218 minus 180. So theta prime would be 38 degrees. So every time you're in quadrant 2, you will take 180 degrees minus theta. Every time you are in quadrant 3, you would take theta minus 180. Okay. If I'm in quadrant 4, so here's where it starts. It's got to end somewhere over here. If it's a positive angle, it goes all the way around to that spot. That would represent theta. All right, if I want the reference angle, that's the positive measure from the end of my ray back to the x-axis. Okay, all of these reference angles are where you would draw a right triangle, and then you could use SOHCAHTOA. All right, so that's what it's trying to get at, the importance of your reference angle. All right, so let's say I gave you 307 degrees for theta. And I want you to find theta prime, or the reference angle. So I'm not going to use 180 this time. I use 180 in quadrant 2 and 3 because everything is coming around having to do with 180 degrees, right? But now I've gone past 180 and I'm focusing on the x-axis, so all the way around would be 360 minus 307, and what's left over would be your 53 degrees. All right, because I can use 53 degrees, 38 degrees, and 25 degrees in a right triangle. I cannot use 155, 218, or 307 in a right triangle trig problem. All right, so these are my non-acute angles, but I can find the reference angle and use that instead. Okay. All right, we'll do a couple more examples of just finding the reference angle. All right, so if I just give you the angle, so negative 250 degrees, we haven't done a negative one yet, or we haven't done one that's more than 360 degrees. If it helps you to sketch them, go ahead and sketch them, but I'll let you try those two here, and then I'll pause. Okay, let's see how you did with those two. All right, so I like to kind of sketch where this is at, especially if it's ones that aren't as obvious. Like I have my first example, this is a negative angle. So it might not be obvious to me where that quadrant is, where that's located. So remember, when your angle is negative, you start in this direction. So I would go around, that would be negative 180. Back to the x-axis would be negative 270. So it's got to stop somewhere over in your second quadrant that represents your theta. All right, my reference angle then, so here's where it ends, and then here's my x-axis. It will be the positive measure of that angle. Okay, so there's a couple different ways you can think about this. Since we are in quadrant 2, it does have something to do with 180, right? Because this makes 180. If you ignored for a second that this is a negative angle, and you think about that this is 180, and then how much more do we need to go to get to 250? So you could take 250 minus 180. To get your remaining 70 degrees. That would be a way to come up with it. If you just kind of ignore it, that's negative and not truly, this side's not truly 250. Some students will kind of like to go the other way, and they'll think about, well, let's figure out what's left here. So if I take 360 minus 250, that would be 110 degrees, makes up that angle, and then I have 70 degrees remaining to get to 180, would be another way to think about it. So up to you how you come up with that. Number 2, for 595, you'll want to figure out where that's at. All right, so if I go all the way around, that's 360. So I got to take 360 away from this, so then I can find that coterminal angle, right? That we talked about coterminal angles, a couple weeks ago now. So then I'd be left with 235 degrees. So then I'll want to use that coterminal angle to figure out where I'm landing. All right, so 235 would go past 180 and land somewhere over here in your third quadrant. So that means there's where my reference angle would be. So my theta prime would be 235 minus 180 to get 55 degrees. Okay. All right. So if you don't have one that is negative or one that's past 360, this will be the general, general formulas, I guess, that you'll use every time for quadrant 2, 3, and 4. Okay. A couple other things we'll take a look at. You may be asked to find the exact value of sine of 135 degrees and cosine of 135 degrees. All right, so if it's the exact value, there's some kind of typically fraction, radical, things in there. Yes, there are ways to do this on your calculator. We'll talk about the ways to do this on your calculator tomorrow, but your calculator will give you the decimal, and that is not the exact value that we are looking for. So we are going to use a lot of the knowledge that we have from what we've done so far in Trig. So if I look at, well, where's this located? Right, 135. That's my start. It's got to go past 90 and before 180, so it's going to land in quadrant 2. That will be important to us. All right. Also, we know certain values for angles at 30 degrees, 45 degrees, and 60 degrees. We made tables last week, whether you were in class or whether you just made it in your notes, but that table was important that we reference back to for your special right triangles, your 30, 60, 90, and your 45, 45, 90 triangle. So here's the point of reference angles. All right, so my reference angle is right here, okay? So I want to find what that angle measure is. So I would take 180 minus 135, and I get 45 degrees. Okay, so if I drew a right triangle here, now I've got a 45, 45, 90 right triangle. All right, so I told you can be familiar with what the side lengths would be from geometry. Or you can make those tables that we've talked about. All right, so basically I'm looking for what is sine of 45 degrees and what is cosine of 45 degrees, because it's similar to the reference angle. They have the same values, except there's something we got to pay attention to with location. All right, so that would be, for sine and cosine, we do 1 over the square root of 2, which is the square root of 2 over 2. Now, that's what it is for sine and cosine at 45 degrees, not necessarily what it is for sine at 135 and cosine at 135. 45 degrees, remember, is truly in the first quadrant, so everything is positive. 135 is in quadrant 2. So we talked about last week, whether sine or cosine or any of your trig functions, would they be positive or negative in a certain quadrant? It asks you those questions. All right, so this means my x would be negative and my y is positive. So for sine of 135, it's square root of 2 over 2, and yes, it is positive because the y is positive. Cosine, remember, uses x over r, and in quadrant 2, your x is negative. So this is a negative square root of 2 over 2. Okay, I love this because we just used almost everything we've learned in trig so far. You have to know how to find the location of 135 degrees. That was the first section that we did. You have to find the reference angle, which is what we just learned today. You're going to find that reference angle, and then you're going to go back to and use our special right triangles for 45 degrees to come up with our ratios. And then we got to figure out, is it positive or negative in that spot? All right, so we are building on everything we have done so far. And that's what I love about trig. It just uses things we've already done. Beautiful. All right. I'll show you one other type of example we will see and continue to build on all of our skills we've got right now. All right, so you may have something that will ask you to find all values of theta if theta is in the interval (0 to 360 degrees. All right, so that's interval notation if you're familiar with that. Some of you from pre-calc are probably very familiar with that. This means it can be 0. This means you'll end at 360. So what that's saying is you can make one revolution around without repeating the same angle, because 0 degrees and 360 degrees is the same exact location. All right, so you'll see that it's just talking about one time around the circle. Otherwise, if it doesn't say that, technically you can go around and around forever and ever and have unlimited answers. Okay, we talk more about that in the trig elective, but here we're focusing on just one time around. All right, so if I say cosine of theta equals negative square root of 3 over 2. So we're finding all the values of theta that would make that true. Okay, so in a sense, kind of like I'm solving the equation for my variable theta. All right, but to do so, I need to be familiar. When I see square root of 3 over 2, I'm either referencing a table that we previously made or your special right triangles, but I'm coming up with what degrees for cosine of what angle gives you square root of 3 over 2 in the tables we've made or from your special right triangles. Okay, you should see that that would be 30 degrees. Okay, so that's what we're going to use, but cosine of 30 degrees is positive square root of 3 over 2. All right, so 30 degrees is not my answer. 30 degrees is the reference angle from the x-axis wherever cosine is negative. Okay, so we got to think about there are two quadrants where cosine is negative. All right, cosine uses x over r. So that means I need the two quadrants where my x values are negative. So quadrant 2 and 3. So there will be two answers that make this true. All right, I need to use my reference angle of 30 degrees. So that means I need to be 30 degrees above the x-axis. That would be a reference angle. But what I'm finding is theta. That's theta prime is my 30 degrees. I need the theta that would make this true. So I'm going to take 180 minus 30 to get 150. So 150 degrees will be one of my answers. The other one comes in quadrant 3, which would also be 30 degrees below the x-axis, because that would be the reference angle for landing in quadrant 3. So to find theta, I need the angle that goes all the way to 30 degrees past 180. So that would be 180 plus 30 for 210 degrees. Okay, so we are working backwards, right? The last problem, I gave you these, so we could figure out where that was at, use the reference angles to find the ratio. Now you're given the ratio, so you take your ratio, figure out what the reference angle would be, pay attention to if they gave you a ratio that was positive or negative, and then find the two quadrants where that would make sense. And so you'll have two angles each time. Okay. Sometimes, so if I gave you a positive square root of 3 over 2, I would have used 30 degrees. All right, so I have a lot of students that will find the reference angle and they put that as their answer, but it's not necessarily part of the answer unless I was given a positive ratio. Okay, that makes sense. So maybe I'll do one more similar to what we just talked about. So if I said, find them all for cosine of theta is the square root of 3 over 2. Okay, if I had you find that one, there's going to be two quadrants where that's true. So we know our reference angle is 30 degrees because we just talked about it. So yes, theta would be 30 degrees, but there will also be another one. So I have a lot of students that when they see that, they'll tell me 30 degrees and they're done. Remember, this can go all the way around. So my two quadrants where cosine is positive, we've got quadrant 1, that's our 30 degrees. But we also have quadrant 4 because x is positive in quadrant 4. So that would be, I'll change my color, all the way around to here. We want to find that theta that's just 30 degrees before 360. So that would be 330 degrees. Okay, so you'll see ones that would say sine of theta is 1/2, or cosecant of theta is the square root of 2, or negative square root of 2. What are your two angles that make that true? Okay, so we're putting together lots of little pieces from what we've been working on over the last couple weeks. All right, and that's our lesson for today. Good luck on your homework.